Okay, class, kindly stand up and we have a prayer. In the name of the Father, Son, Holy Spirit, Amen. Lord, guide us, protect us, and Lord, give knowledge to us, strength, and Lord, sana magtawad mo ang aming mga nagawang kasalanan. In Jesus' name, Amen. In the name of the Father, the Son, and the Holy Spirit, Amen. Good morning, class! How are you today? Before we start our discussion, I have here our Philippine flag. So, do you know what the color of our Philippine flag stands for? Okay. So, what is the meaning of blue? Okay. Very good. It symbolizes justice, peace, and the truth. Okay. How about the red? Okay. Very good again. Yes, it symbolizes a patriotism and valor. And do you know that not only the color of our Philippine flag has meaning. Resistor has a color and meaning too. So, what is our lesson for today, class? So, what is resistor? Okay? Very good. For now, we can proceed now to understanding the color code, the resistor or the understanding the resistor color code. Resistor color code, manufacturers typically use a color band system known as the resistor color code. Within this PowerPoint, you will learn how to identify the nominal resistance and tolerance of a resistor. The power rating is not indicated in the resistor color code and must be determined by experience using the physical size of resistor as a guide. For resistor with positive and negative or negative 5% and positive and negative 10% tolerance, the color code consists of 4 color bands. And for resistor with positive or negative 1% and positive or negative 2% tolerance, the color code consists of 5 bands. In a 4-band resistor, the resistor nominal value is encoded in a color code in power of 10 notation. The template of determining the nominal value in the tolerance of a resistor with 4 color bands is given below. So that's a 4-band resistor, which consists of the first band or the first digit, and second band, and then the third band, which is the multiplier, and then the fourth band, which is the tolerance. So, how do we know which color corresponds to which number? Okay? Yes, using the resistor or color code table. That's it. Under the resistor color code table, we have the color, digit, and the multiplier, and then the tolerance. In a color, there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There are 12 color, and we are going to consider the no band or no color. And the first one is the black, which is the digit is 0, Second one, brown, which is the number 1, red, 2, orange, 3, yellow, number 4, the green, 5, and the blue, number 6, the violet, 7, and the gray, 8, and the white is number 9. And the silver and gold is, which is, you are going to have the tolerance of positive under 4 band resistor, the positive and negative 10%, and the gold is positive or negative 5%. If we are going to solve the 5 band resistor, you are going to use, if we are going to solve the tolerance, you are going to use the positive or negative 1% and then positive and negative 2%. Okay, if the given tolerance is no color, you are going to use positive and negative 20%. Example number 1. Determine the nominal resistance value in the tolerance for the resistor shown below. That's it. In this example, you're going to solve the nominal value, which is in the first digit or first band, it's the color brown, which is number of 1, and then the second color band is the black, which is 0, times in the multiplier of the red, which is the 2, 10 times 10 raised to 2 ohms, and then the tolerance is the positive and negative 5%, which is, if we are going to solve this one, it is equals to 1000 ohms. It is typically expressed the resistance value in kilo ohms if the resistance is greater than 1000 ohms, and million ohms if the resistance is greater than 1 million ohms. To convert from ohms to kilo ohms to ohms to million ohms or vice versa, use the table below. In the previous example, we would say a resistor has a nominal value of 1000 or 1000 ohms, or 1000 is or equals to, or the 1000 ohms divided by 1000 is equal to 1 kilo ohms. So that's the table of conversion table. If we are going to convert from ohms to kilo ohms, the action is divided by 1000. And if we are going to convert from ohms to million ohms, the action is divided by 1 million. If we are going to convert from kilo ohms, we're going to convert from kilo ohms to ohms, the action is multiplied by 1000. And if you are going to convert from million ohms to ohms, the action is multiplied by 1 million. Okay? Example number 2. Determine the nominal value in tolerance for the resistance below. And letter B, what is the minimum resistance value this resistor can actually have, and also the maximum resistance value this resistor can actually have. Okay? The resistor nominal value is equal to 47 times 10 raised to 3 ohms. Why? Because in the first band is yellow, which is the 4, and then the second band is violet, which is 7 times 10 raised to 3, which because orange is 3, and then the tolerance is gold, or equal to positive or negative 5%. if we are going to solve the resistor nominal value, we are going to times the 47 times 10 raised to 3 ohms is equal to 47,000 ohms. And minimum resistance value, we are going to multiply the nominal value by the tolerance and then subtract this from the nominal value. So that's it. And then if we go to maximum resistance value, you can also multiply the nominal value by the tolerance and then add. Ang kaibahan lang doon kasi, in minimum resistance value, you are going to subtract. And at dito naman sa maximum resistance value, we are going to add. Yun ang kaibahan po. Okay, let's proceed to 5-band resistor. 5-band resistor. For resistor with positive or negative 1% or positive or negative 2% to the tolerance, the color code consists of 5 bands. Remember, negative and positive 1% or positive and negative 2% consists of 5 bands. So the template for 5 bands resistor is like this. We are 1, 2, 3, 4, 5 color bands. Unlike in the 4 bands resistor that they are only have 4 colors. So in the first color or the first band, you are going we have the first significant digit, and the second is the second significant digit, and the third is significant digit also, and in the fourth band, which is the multiplier, and then the fifth band is the tolerance. For example, determine the nominal resistance and tolerance for the resistor shown below. Oh, that's it. The resistor nominal value is equal to 100 times 10 raised to 1 ohms. Why? Because in the first band is brown, which is 1. That's it. And the second band is black, which is 0. That's it. And then the third band is black again, so 0. Times the multiplier is the brown again, so 1. So which is equivalent to 10 only. So 10 times 1. Now next is the tolerance, the red, which is equivalent to positive and negative 2%. So if we are going to solve the resistor nominal value, 100 times 10 raised to 1 ohms is equal to 1000 ohms. If we are going to convert this one to kilo ohms, like I discussed earlier, and if we are going to convert the ohms to kilo ohms, we are going simply to divide 1000 ohms divided by 1000. So we can get the 1000 kilo ohms, and then the tolerance is positive or negative 2%. Next, converting the nominal resistance and tolerance in a color code. In a 4-band resistor, there are 6 that we are going to follow. Resistance with positive and negative 5% and positive and negative 10% tolerance will have 4 bands. So convert nominal value to ohms. First digit from left to right of nominal value, first color band. And the second digit of nominal value is the second band. And the number of 0 remaining, which is the third band, is the multiplier. And last one is the tolerance, which is the fourth band. Example, specify the color code of resistor with nominal value of 27 kilo ohms and a tolerance of positive and negative 10%. Since the resistor tolerance is positive and negative 10%, it will have 4 bands. So we are going to convert the nominal resistance value of ohms from kilo ohms. Like this one. So in the first band, which is red, is represent number 2, is 1, and the second digit violet 7. In the third band, which is the multiplier orange 3, which is 1, 2, 3, 0 ohms, and then the tolerance is positive or negative 10%. How do we solve Y 27,000 ohms? Simply, we are going to convert the nominal resistance value of ohms from kilo ohms. Simply that, if we are going to convert 27,000 times 1,000, so we can get the 27,000 ohms. And the 5-band resistor, there are 7 that we are going to follow. Unlike in the 4-band resistor, unlike in 4-band resistor, the multiplier is in the third band. In this 5-band resistor, the multiplier is in the fourth band. So the resistor will positive and negative 1% and positive or negative 2%. Tolerance will have 5 bands and convert nominal value to ohms. And the first digit from left to right, nominal value is equal to first color band. And the second digit of nominal value is equal to second band. And the third digit of nominal value is equal to third band. And the number of 0 remaining. This is what I said earlier. This is the multiplier, which is the fourth band. And then the tolerance is equal to in the fifth band. Example, specify the color code of a resistor with nominal value of 2.5 million ohms and a tolerance of positive and negative 1%. Okay, since this resistor tolerance is equal to positive and negative, it will have 5 bands. Convert this also to nominal resistance value of ohms from million ohms. Like what I said. And for this lesson, we use color coding in a resistor because it's for easier identification. Using this, you can calculate the resistance in a resistor just by using in a color bands. And why does have a resistor have a tolerance? Because there is no perfect resistor with an exact value. Resistor manufactured in approximity values. So next, we are going to have an exercises which is So next is we are going to have an exercises. In this exercises, you are going to observe the following pictures and then solve it. Write your answers and a 1/2 crosswise paper. So we are going to solve this one. This one is, the first band is orange, so 3. And second band is white, so we are going to insert the number 9 times the multiplier of green, which is 5. And then the tolerance is silver, so the positive, negative 10%. If we solve the resistor nominal value, the answers that we got is the 3.9 million ohms. How? The 39 times 10 raised to 5, para mas madali nyong makuha yung sagot. Itong raised to 5 na to, you are going to add the 39 plus 5 is equivalent to, you can write the 5 zeros, 1, 2, 3, 4, 5, 3,900,000. So that's the resistor nominal value, 3,900,000, or if we are going 3,900,000 ohms, or we are going to convert in million ohms, 3.9 million ohms. And the tolerance is the 10%. If we are going to solve the minimum resistor value, we are going to subtract. And this one, the 3.9 million ohms minus 3.9 million ohms times, we are going to convert the tolerance, which is 0.1%. And if we are, the first that we are going to solve is 3.9 million ohms times 0.1, which is equal to 0.39 million ohms, that we are going to minus in 3.9 million ohms. The answer is 3.51 million ohms. And in maximum resistor value, we are going to add same solution, but we are going to add the 3.9 million ohms plus 3.9 million ohms times 0.1. We are going to times first the 3.9 million ohms times 0.1. We got the 0.39 million ohms, and then we are going to add the 3.9 million ohms plus 0.39 million ohms. We got the 4.29 million ohms. Okay? We are now proceed to the next activity that you are going to solve, and write your answer in one half crosswise paper again, and then identify the resistor value in the powers of 10 notations. Letter A, and then letter B, determine the colors of the resistor. Okay? We will now proceed answering. Okay, class, are you done? Let's begin to solve your exercises. Okay, this is the answer of number 1, number 2, number 3, number 4, number 5, and letter E. And this is the answer also in letter B, and 1 until 5. Why? Let's go back to your activity. The answer of number 1 is 10 times 10 raised to 1 ohms plus the negative 5%. Why? Because the brown is equivalent number of 1. Right there, 1. And the black is equivalent number of 0. 0 times the multiplier is brown. So the multiplier there is 1. And the tolerance is 5, positive, negative 5% because the color band is gold. And number 2, red, green, orange, silver. Oh, this is the answer because the red is equivalent number of 2 and the green is equivalent number of 5 times 10 raised to 3. What is the equivalent of 3? Color is orange. So the tolerance is positive and negative 10% because the color band is silver. And the number 3, brown, green, orange, silver. And brown is equivalent number 1. And the green is 5. 3. And the positive, negative 10%. The color band is silver. And the answer of number 4 is 94 times 10 raised to 4 ohms plus negative 10%. Why? Because the 94 is equivalent of white and yellow. And the multiplier is yellow and the tolerance is the silver. And number 5, green, violet, blue, gold. In a green, the number equivalent is 5. And then the violet is 7 times the multiplier 6 ohms that we are going to convert in ohms. So the color is blue and the tolerance is positive, negative 5% because it is gold. And then dadako naman tayo sa litrang B. The answer of number 1 is brown, red, gold because from the activities, the brown is equivalent of 1 and the red is equivalent of 2, positive, negative 5% because it is gold. And number 2, yellow, violet, gold. Why? Because the yellow equivalent number of 4 and the violet equivalent number of 7 and the positive and negative 5% which is gold. Number 3, brown, black, black, silver. Why? Because the brown is equivalent number of 1, the black 0, black again 0 plus the negative 10% because the color band is silver. And then number 4 is orange, violet, orange, gold. Why? Because the orange is equivalent number of 3 and then the violet equivalent number of 7 and the multiplier is orange is multiplier 3. So we are going to convert this one and ohms, simply add 3 0 and positive negative 5% is the color band is gold. And number 5, red, red, blue, silver. Why red, red, blue, silver? Because the equivalent number of red is 2, red again, equivalent number 2, and then equivalent number of blue is the multiplier, so meaning you can add the 1, 2, 3, 4, 5, 6 because blue is an equivalent number of 6. And then the positive and negative 10%, which is the silver color band. And that's all. Thank you and God bless. Okay, class, your assignment is you are going to research or cite on how to troubleshoot a resistor because next meeting will be our next lesson and we are going to have a recitation in this lesson. Thank you and God bless.